Picture this: thousands of broken satellites, spent rocket stages, and fragments of metal hurtling through space at unimaginable speeds. This isn't a scene from a sci-fi movie, it's our reality. Right now, over 170 million pieces of space debris are orbiting Earth, turning our skies into a dangerous minefield. The problem is growing faster than ever, and if we don't act soon, it could jeopardize everything from satellite communications to future missions to Mars. But here's the good news: the same ingenuity that got us into this mess might just get us out of it. Innovative technologies are emerging to tackle this colossal challenge, and they're reshaping the future of space exploration as we know it. In this video, we'll dive into 50 specific predictions about the future of space debris cleanup, exploring everything from artificial intelligence-powered tracking systems to orbital recycling stations. These advancements aren't just about cleaning up the cosmos, they're about securing humanity's place among the stars. So, if you're ready to discover how we're turning this crisis into an opportunity, keep watching. The future of space is being written right now, and it's more exciting than ever. Now, let's take a closer look at how artificial intelligence is stepping up to tackle the space debris crisis. Artificial intelligence-powered debris tracking systems are set to completely transform the way we monitor and manage the clutter in orbit. Imagine a system that can analyze vast amounts of data in real time, identifying the location, speed, and trajectory of every piece of debris with pinpoint accuracy. These advanced systems won't just passively track objects, they'll predict potential collisions before they happen, giving us the chance to take action and avoid disaster. By combining machine learning with powerful algorithms, artificial intelligence will not only improve our ability to catalog debris, but also help us understand how it moves and evolves over time. This isn't just about keeping satellites safe. It's about creating a smarter, more efficient way to navigate the challenges of space. With artificial intelligence at the helm, we're moving toward a future where space debris is no longer an unpredictable threat but a manageable problem. Now, let's shift our focus to another groundbreaking innovation that's set to redefine space debris cleanup: autonomous space drones. Picture small, nimble spacecraft equipped with advanced sensors and robotic arms, designed to navigate the vastness of space with precision and efficiency. These drones will operate without human intervention, relying on sophisticated algorithms to identify, capture, and deorbit small pieces of debris. Imagine a fleet of these drones working in unison, scanning the skies for fragments as small as a bolt or as large as a discarded satellite panel. Once detected, they'll use their robotic arms to securely grasp the debris and guide it toward Earth's atmosphere, where it will safely burn up upon re-entry. This approach not only reduces the risk of collisions, but also minimizes the need for costly and complex human-led missions. By leveraging autonomy and cutting-edge technology, these drones promise to make space debris cleanup faster, safer, and more scalable. It's a glimpse into a future where we can actively maintain the cleanliness of our orbital environment, ensuring it remains a safe and sustainable frontier for exploration. Moving forward, let's explore another fascinating approach to tackling the space debris problem: laser-based debris removal. Imagine powerful lasers both on Earth and in space, targeting tiny fragments of debris orbiting our planet. These lasers won't just zap the debris into oblivion, they'll either vaporize it entirely or gently nudge it out of orbit, ensuring it falls harmlessly into Earth's atmosphere where it will burn up. Ground-based lasers can focus their energy on debris in lower orbits, while space-based lasers can handle objects further out, creating a comprehensive system for debris management. This method is particularly effective for smaller pieces of debris that are difficult to capture with nets or drones. By precisely targeting and removing these hazardous fragments, lasers reduce the risk of collisions that could create even more debris. It's a high-tech solution that combines precision with efficiency, offering a cleaner and safer orbital environment. With advancements in laser technology, this approach could soon become a cornerstone of our efforts to preserve space for future exploration. Now, let's turn our attention to another innovative solution in the fight against space debris: the use of space nets and tethers. Picture this: specialized spacecraft equipped with large, deployable nets and flexible tethers, designed to capture and secure large debris objects like defunct satellites or rocket stages. Once captured, these nets and tethers can safely guide the debris into Earth's atmosphere, where it will burn up during re-entry. This method is particularly effective for managing larger pieces of debris that are too big for lasers or drones to handle. The controlled re-entry ensures that these objects don't pose a threat to active satellites or future space missions. By focusing on larger debris, nets and tethers address one of the most significant risks in orbit: the potential for catastrophic collisions that could create thousands of smaller, harder-to-track fragments. It's a simple yet highly effective approach, combining proven technology with strategic planning to keep our orbital environment clean and safe. As this technology continues to evolve, it could play a crucial role in maintaining the sustainability of space for generations to come. Now, let's shift gears to an exciting and forward-thinking idea: orbital recycling stations. Imagine facilities in space dedicated to transforming space debris into valuable raw materials. These stations would collect discarded satellites, rocket parts, and other debris, then break them down into metals, plastics, and other components. These materials could then be used for in-space manufacturing and construction, reducing the need to launch resources from Earth. This approach not only tackles the debris problem but also turns it into an opportunity for sustainability. By repurposing what was once considered waste, orbital recycling stations could support the construction of new satellites, space habitats, or even deep space missions. It's a win-win solution, cleaning up our orbit while providing the building blocks for humanity's future in space. As this concept gains traction, it could revolutionize how we think about resource management beyond our planet, paving the way for a more sustainable and efficient space economy. Moving forward, let's explore another innovative approach to space debris cleanup: magnetic debris collection. In low Earth orbit, much of the debris consists of metallic materials like aluminum and titanium, remnants of old satellites and rocket parts. Magnetic fields could be harnessed to attract and gather these metallic fragments efficiently. Imagine spacecraft equipped with powerful magnets designed to sweep through orbit, pulling in debris like a cosmic cleanup crew. This method would be particularly effective in areas where metallic debris is densely concentrated, reducing the risk of collisions and creating cleaner orbital pathways. By focusing on metallic waste, magnetic debris collection offers a targeted and practical solution, complementing other cleanup technologies. It's a fascinating example of how simple yet powerful principles can be applied to address complex challenges in space, paving the way for safer and more sustainable exploration. Now, let's shift our focus to another groundbreaking approach: space tugs for large debris. Picture this: massive defunct satellites, rocket stages, and other sizable objects cluttering Earth's orbit. These pose a significant threat due to their size and potential to break into countless smaller, hazardous fragments. Enter space tugs, specialized spacecraft engineered to attach themselves to these large debris objects and guide them out of orbit. Equipped with advanced grappling systems and propulsion technology, these tugs can safely maneuver these hefty pieces toward the Earth's atmosphere, where they'll burn up upon re-entry. This method not only clears valuable orbital space, but also prevents catastrophic collisions that could generate even more debris. Space tugs represent a targeted and efficient solution, particularly for the most dangerous and cumbersome objects in orbit. By tackling the largest debris first, we take a significant step toward a cleaner, safer space environment, ensuring that future missions can proceed with fewer risks. This innovative approach highlights how precision and engineering can combine to solve some of the most pressing challenges in space exploration. Moving forward, let's explore an exciting innovation that could redefine satellite durability: self-healing satellite shields. Imagine a satellite flying through space, constantly exposed to tiny but fast-moving debris particles. These micro-debris impacts, though small, can cause significant damage over time, compromising the satellite's functionality and lifespan. But what if the satellite could repair itself? Enter self-healing materials, cutting-edge substances designed to automatically seal cracks or holes caused by debris collisions. These materials work by embedding microscopic capsules or networks within the satellite's outer layer. When damaged, these capsules release a special compound that fills the breach, restoring the shield's integrity. This technology not only extends the operational life of satellites, but also reduces the need for frequent debris removal missions. By minimizing the risk of damage, self-healing shields help maintain the efficiency of critical space infrastructure, from communication satellites to scientific probes. This innovation highlights how material science can play a pivotal role in solving space debris challenges, ensuring that our vital orbital assets remain functional and resilient in the face of constant threats. Now, let's turn our attention to a game-changing approach in the fight against space debris: debris mapping satellites. Picture this: specialized satellites designed solely to track and map the vast amount of debris floating in Earth's orbit. These satellites are equipped with advanced sensors and imaging technology capable of capturing high-resolution data about the location, size, and trajectory of debris objects. This information is critical for improving the efficiency and accuracy of cleanup missions. With precise mapping, we can identify the most problematic debris clusters, predict potential collisions, and prioritize removal efforts where they're needed most. Think of it as a detailed roadmap for navigating and cleaning up the orbital environment. By providing a clearer picture of the debris landscape, these satellites empower both government agencies and private companies to plan and execute cleanup operations with greater precision. This technology also plays a key role in enhancing safety for active satellites and spacecraft, ensuring they can operate with reduced risk of collision. As space becomes more crowded, debris mapping satellites will be essential tools in maintaining a sustainable and functional orbital ecosystem, paving the way for safer and more ambitious space exploration in the future. Now, let's shift gears to a crucial yet often overlooked aspect of space debris cleanup: international cooperation. Imagine a world where nations come together to address the growing issue of orbital waste through legally binding agreements. This is the future we're headed toward with the establishment of global space debris treaties. These treaties will aim to regulate the removal of debris, ensuring that all parties involved follow standardized guidelines and protocols. By holding nations accountable for their contributions to the problem, these agreements will incentivize responsible behavior in space operations. Think of it as a collective effort to maintain the orbital environment as a shared resource, much like international treaties on climate change or ocean preservation. These treaties will also outline clear responsibilities for debris cleanup, requiring countries and private entities to take active steps in removing their defunct satellites and other space junk. Additionally, they'll establish frameworks for monitoring and enforcement, ensuring compliance and transparency. This global approach not only fosters collaboration among nations, but also levels the playing field, encouraging innovation and investment in cleanup technologies. As space becomes increasingly crowded, these treaties will play a pivotal role in ensuring that the orbital environment remains safe and sustainable for future generations of space exploration. Now, turning our attention to an innovative solution that could revolutionize the efficiency of debris cleanup, let's consider the potential of space-based solar power. Picture this: vast solar arrays orbiting the Earth, harnessing the sun's energy without the interference of our atmosphere. these space-based solar power stations could serve as a game-changer for debris removal missions. By providing a continuous and abundant energy source, they would eliminate the need for traditional fuel-based propulsion systems, making cleanup operations more sustainable and cost-effective. Imagine a fleet of debris removal spacecraft equipped with advanced solar panels, drawing power directly from these orbiting stations. This setup would allow them to operate for extended periods without refueling, significantly increasing their efficiency. Additionally, the energy harvested from these solar stations could power high-capacity systems like lasers or robotic arms, enabling more effective debris capture and deorbiting. The integration of space-based solar power into debris cleanup efforts would not only reduce the environmental impact of these missions, but also set a precedent for sustainable space exploration. As we continue to innovate, this approach could pave the way for a cleaner, safer orbital environment, ensuring that future generations can explore the cosmos without the hindrance of space debris. Now, let's explore an emerging trend that's transforming the way we tackle space debris: debris removal as a service. Picture a future where private companies step into the spotlight, offering specialized cleanup services to governments and satellite operators. As the demand for debris removal grows, these companies could become essential players in maintaining a clean and safe orbital environment. By leveraging cutting-edge technologies and innovative business models, they would provide tailored solutions for removing debris, whether it's defunct satellites, spent rocket stages, or smaller fragments. This approach would allow governments and space agencies to focus on their core missions while outsourcing debris cleanup to experts. Imagine a subscription-based model where companies offer regular debris removal services, ensuring that orbital paths remain clear and functional. This could not only reduce the financial burden on public institutions, but also accelerate the pace of cleanup efforts. Additionally, private companies could compete to develop faster, more efficient, and cost-effective methods, driving innovation in the field. As debris removal becomes a service-oriented industry, it could open up new opportunities for collaboration between the public and private sectors, fostering a shared responsibility for preserving our space environment. This shift could mark a significant step toward a more sustainable and organized approach to managing space debris, paving the way for safer and more ambitious space exploration. Now, let's take a leap into the future with a groundbreaking concept: space elevators for debris transport. Imagine a giant structure stretching from Earth's surface into orbit, acting as a celestial conveyor belt. These space elevators could revolutionize how we handle space debris by providing a cost-effective and efficient way to transport it back to Earth. Instead of relying solely on rockets or specialized spacecraft, debris could be captured in orbit and then guided down to the planet's surface using these elevators. Once back on Earth, the materials could be recycled or safely disposed of, reducing waste and reclaiming valuable resources. This approach would not only streamline the cleanup process, but also minimize the environmental impact of traditional debris removal methods. Space elevators could become a game-changer, making it easier to maintain a clutter-free orbital environment while supporting sustainable practices. As technology advances, these structures could also open up new possibilities for transporting other materials and equipment between Earth and space, further transforming how we explore and utilize the cosmos. The development of space elevators could mark a pivotal moment in our journey toward a cleaner and more sustainable space environment. Moving on to a forward-thinking solution, let's talk about the potential of biodegradable satellites. Imagine a future where satellites, once they've completed their missions, don't linger in orbit as hazardous debris, but instead break down naturally into harmless materials. This concept hinges on the development of advanced materials designed to degrade over time in the harsh conditions of space. These materials would be engineered to withstand the rigors of their operational lifespan, but begin to disintegrate once their usefulness has ended. By using biodegradable components, we could significantly reduce the accumulation of space debris, ensuring that our orbital environment remains clear and safe for future missions. This approach not only tackles the issue of debris but also promotes sustainability by minimizing waste. It's a proactive step toward preventing the problem before it even arises, offering a cleaner and more responsible way to conduct space exploration. As research into these materials progresses, biodegradable satellites could become a standard in the industry, helping us protect the orbital pathways that are so crucial to global communication, scientific research, and space travel. This innovation could mark a significant shift in how we design and deploy satellites, paving the way for a more sustainable future in space. Now, let's consider an unexpected yet practical solution to the space debris problem: space debris insurance. As the risks posed by orbital clutter continue to grow, insurance companies are likely to step in with specialized policies designed to cover damages caused by debris collisions. These policies could protect satellite operators, space agencies, and even private companies from the financial fallout of debris-related incidents. By shifting some of the financial burden onto insurers, these policies would create a strong incentive for organizations to invest in debris cleanup technologies and practices. After all, the fewer debris in orbit, the lower the risk of costly collisions, and the lower the premiums for coverage. This market-driven approach could spur significant advancements in debris removal efforts, as companies work to reduce their liabilities and insurers push for safer orbital environments. Over time, space debris insurance could become a standard part of space operations, encouraging a culture of responsibility and sustainability. It's a fascinating example of how financial mechanisms can drive positive change in an industry, turning the challenge of space debris into an opportunity for innovation and collaboration. Now, let's look at another innovative approach that could transform the way we track and monitor space debris: crowdsourced debris tracking. Imagine a future where everyday citizens and amateur astronomers contribute to the effort of identifying and cataloging orbital clutter. Through apps and online platforms, people around the world could report sightings of debris, share observations, and even analyze data from telescopes or satellites. This collective effort, known as citizen science, has the potential to significantly enhance our understanding of debris patterns and movements. By tapping into the power of crowdsourcing, space agencies and researchers could gather a wealth of data that would otherwise be difficult or expensive to obtain. This approach not only increases the amount of information available, but also engages the public in a meaningful way, raising awareness about the issue of space debris. Over time, crowdsourced debris tracking could become a vital tool in our efforts to keep Earth's orbit clean and safe. It's a powerful example of how collaboration between professionals and everyday people can lead to innovative solutions for global challenges. Expanding the conversation, let's consider a more creative approach to space debris cleanup: transforming collected debris into art installations. Imagine pieces of defunct satellites, rocket fragments, and other orbital clutter being repurposed into striking sculptures or exhibits. These installations could serve as powerful visual reminders of the growing problem of space debris, sparking conversations and inspiring action. By placing these works in public spaces, museums, or even online galleries, artists and scientists could collaborate to highlight the urgency of addressing this issue. Beyond raising awareness, such projects could also foster a deeper connection between the public and the challenges of space exploration. Art has a unique ability to communicate complex ideas in ways that resonate emotionally, making it an ideal medium to convey the importance of keeping our orbits clean. This fusion of science and creativity not only gives new life to discarded materials, but also transforms them into tools for education and advocacy. It's a reminder that even in the vastness of space, our actions have consequences, and that innovation can come in unexpected forms. Shifting our focus to the next frontier of space debris cleanup, let's explore the role of education in shaping a sustainable future for space exploration. Space debris education programs will play a crucial role in equipping the next generation of scientists, engineers, and policymakers with the knowledge and skills needed to tackle this growing challenge. These initiatives could take many forms, from school curriculums and university courses to workshops, online tutorials, and public outreach campaigns. By integrating space debris cleanup into science, technology, engineering, and math or STEM programs, students will gain a deeper understanding of the problem and the innovative solutions being developed to address it. Beyond formal education, public awareness campaigns can help people of all ages grasp the significance of keeping our orbits clean. Imagine interactive exhibits, documentaries, and even virtual reality experiences that simulate the process of tracking and removing debris. These tools not only educate but also inspire curiosity and creativity, encouraging more people to contribute to the field. Additionally, partnerships between educational institutions, space agencies, and private companies can provide hands-on learning opportunities, such as internships, research projects, and competitions focused on debris cleanup technologies. By fostering a culture of awareness and innovation, these programs will ensure that space debris cleanup becomes a shared responsibility. After all, the future of space exploration depends on our ability to educate and empower the problem solvers of tomorrow. Moving forward, we can expect the rise of space debris removal competitions to spark a wave of innovation in this critical field. These challenges will bring together students, researchers, and entrepreneurs to tackle the problem of orbital waste in creative and practical ways. Competitions could range from designing efficient debris capture mechanisms to developing algorithms for tracking and predicting debris movement. By offering prizes and recognition, these contests will incentivize participants to push the boundaries of what's possible in debris cleanup. Additionally, such events will foster collaboration across disciplines, encouraging engineers, scientists, and even artists to contribute their unique perspectives. Imagine teams from universities and startups competing to create the most effective debris removal prototype, with judges evaluating their designs based on factors like cost, scalability, and environmental impact. These competitions will not only accelerate technological advancements, but also raise awareness about the urgency of the debris problem. Furthermore, winning solutions could attract funding and support, transforming innovative ideas into real-world applications. As these challenges gain momentum, they will inspire a new generation of problem solvers to take on the task of keeping our orbits clean, ensuring that space debris cleanup remains a dynamic and evolving field of progress. Now, let's delve into how governments and organizations will play a pivotal role in driving space debris cleanup through recycling incentives. Picture this: as the issue of orbital waste grows, policymakers and leaders will introduce programs designed to encourage companies to transform debris into valuable resources. These incentives could take the form of grants, tax breaks, or even subsidies for businesses that develop technologies to recycle space junk. By turning debris into raw materials for in-space manufacturing or construction, companies could not only contribute to a cleaner orbit but also unlock new economic opportunities. Governments might also create markets for recycled space materials, offering contracts or guarantees to those who repurpose debris effectively. On an international level, organizations could establish collaborative initiatives where countries share resources and expertise to maximize the impact of recycling efforts. Imagine a future where defunct satellites are not just hazards but sources of rare metals or components for new spacecraft. These incentives will not only accelerate the pace of debris cleanup but also foster innovation in recycling technologies. By making it financially rewarding to tackle orbital waste, governments and organizations will ensure that space debris cleanup becomes a sustainable and economically viable endeavor. This approach will encourage a shift from viewing debris as a problem to seeing it as a potential resource. paving the way for a cleaner and more efficient space environment. Shifting our focus to the financial side of space debris cleanup, let's explore how tax credits could become a game changer in incentivizing companies to tackle orbital waste. Imagine governments offering tax breaks to businesses that invest in developing or deploying debris removal technologies. These credits would not only reduce the financial burden on companies, but also encourage innovation in a field that's crucial for the future of space exploration. Picture this: a company that launches a satellite equipped with debris capturing technology could receive significant tax benefits, making the investment more appealing. Similarly, startups working on groundbreaking cleanup solutions might find it easier to secure funding if tax incentives offset their initial costs. Governments could also tailor these credits to prioritize specific technologies, such as autonomous drones or laser-based systems, accelerating progress in high-impact areas. On a broader scale, tax credits could foster international collaboration, as countries adopt similar policies to create a level playing field. By aligning financial incentives with environmental goals, tax credits would not only make space debris cleanup more accessible, but also transform it into a profitable venture. This approach could attract a wave of new players into the industry, while ensuring that the responsibility of maintaining a clean orbit becomes a shared global effort. With these incentives, the path to a debris-free space becomes not just a necessity but an economically smart move. Now, let's take a closer look at an innovative approach that could redefine how we tackle space debris: swarms of small drones working together. Picture a fleet of compact, highly efficient drones, each equipped with advanced sensors and robotic arms, collaborating to capture and remove debris from orbit. Unlike traditional methods, which often rely on a single, large spacecraft, these drone swarms would operate in unison, dividing tasks and covering vast areas of space more effectively. For instance, one drone might identify debris, while another positions itself to capture it, and a third transports it to a designated deorbiting zone. This division of labor not only speeds up the cleanup process but also reduces the risk of failure, as the swarm can adapt if one drone encounters issues. The drones could be designed to communicate in real time, sharing data and coordinating their actions to maximize efficiency. Imagine these swarms being deployed in low Earth orbit, where debris is most concentrated, working tirelessly to clear the way for satellites and spacecraft. What's particularly exciting is that these drones could be reusable, returning to a central hub for refueling or repairs before heading back into action. This approach would not only make debris removal more cost-effective but also scalable, allowing us to address the growing problem of orbital waste with precision and agility. By leveraging the power of collaboration, swarms of drones could become a cornerstone of future space debris cleanup efforts, ensuring a safer and more sustainable environment for space exploration. Moving forward, let's explore how artificial intelligence will take space debris cleanup to the next level. Imagine sophisticated algorithms that can analyze vast amounts of data in real time, identifying the most urgent debris targets and plotting the most efficient paths to remove them. These artificial intelligence algorithms won't just track debris, they'll prioritize it based on factors like size, trajectory, and potential risk to active satellites or spacecraft. By processing this information instantly, artificial intelligence can guide cleanup missions with precision, ensuring that resources are used effectively and collisions are avoided. For example, an algorithm might determine that a large piece of debris in a crowded orbit poses a significant threat and should be addressed immediately, while smaller, less dangerous pieces can be handled later. This level of optimization would make debris removal faster, safer, and more cost-effective. What's more, these algorithms could continuously learn and improve over time, adapting to new challenges as the debris landscape evolves. Think of it as a highly intelligent navigation system for space cleanup, one that can think several steps ahead to keep our orbits clear. By integrating artificial intelligence into debris removal strategies, we'll be able to tackle this growing problem with unprecedented efficiency, paving the way for safer and more sustainable space exploration. Now, let's turn our attention to a groundbreaking approach that could redefine how we manage space debris: dedicated satellites designed exclusively for debris removal missions. These specialized satellites will be engineered with one sole purpose: to locate, capture, and safely deorbit debris from orbit. Unlike traditional satellites that focus on communication or observation, these cleanup satellites will be equipped with advanced tools like robotic arms, nets, and even propulsion systems designed to maneuver debris into controlled re-entry paths. Picture a satellite that can identify a piece of debris, navigate toward it with precision, and either capture it or push it out of orbit entirely. This targeted approach will allow us to tackle debris more efficiently, addressing both large and small objects that pose risks to active missions. One of the most exciting aspects of these satellites is their scalability. They can be deployed in swarms to handle multiple debris pieces simultaneously, or as individual units for more complex or high-risk targets. Additionally, their design will likely incorporate modular components, making them easier to upgrade or repair as technology advances. By dedicating entire satellites to debris removal, we're not just addressing the symptoms of the problem, we're creating a proactive solution that could significantly reduce the debris population over time. This innovation marks a crucial step toward cleaner, safer orbits, ensuring that space remains accessible for future exploration and discovery. Moving forward in our exploration, let's shift our focus to the power of collaboration in solving the space debris crisis. One of the most promising developments on the horizon is the rise of partnerships between governments, private companies, and international organizations. Imagine a scenario where nations pool their resources, expertise, and technologies to address this global challenge collectively. Governments can provide the regulatory framework and funding, while private companies bring innovation and agility to the table. International organizations, on the other hand, can facilitate coordination and ensure that efforts are aligned on a global scale. These partnerships will be essential in creating standardized protocols for debris removal, sharing data, and avoiding duplication of efforts. For example, a private aerospace company might develop cutting-edge debris capture technology, while a government agency ensures its deployment aligns with international space laws. Meanwhile, an organization like the United Nations could oversee the equitable distribution of responsibilities and resources among participating countries. This collaborative approach not only accelerates progress but also ensures that the burden of debris cleanup is shared fairly. By working together, these diverse entities can achieve what none could accomplish alone: a sustainable and debris-free orbit for future generations. This prediction highlights the importance of unity in tackling a problem that transcends borders, proving that space debris cleanup is not just a technological challenge but a global responsibility. Now, let's turn our attention to the critical role of research and development in advancing space debris cleanup technologies. One of the most impactful catalysts for innovation in this field will be the expansion of research grants. Picture this: governments, private organizations, and even philanthropic entities dedicating significant funds to support groundbreaking studies and experiments. These grants will empower scientists, engineers, and startups to explore new ideas, test prototypes, and refine technologies that were once considered too risky or expensive to pursue. For instance, a research grant might fund the development of a novel material that can withstand the harsh conditions of space while capturing debris more efficiently. Another could support the creation of advanced algorithms that optimize debris removal missions with precision. As funding increases, so too will the pace of discovery, leading to faster and more cost-effective solutions. Beyond technological advancements, these grants will also foster collaboration across disciplines, bringing together experts in aerospace, robotics, sustainability, and artificial intelligence. This influx of resources will not only accelerate progress, but also inspire the next generation of innovators to tackle the debris challenge with fresh perspectives. By investing in research today, we lay the groundwork for a cleaner and safer orbital environment tomorrow. This prediction underscores the importance of sustained financial support in unlocking the full potential of space debris cleanup technologies, ensuring that the tools we need are not just imagined but realized. Moving forward, let's consider how public awareness will shape the future of space debris cleanup. Media and campaigns will play a pivotal role in highlighting the urgency of this issue, transforming it from a niche concern into a global priority. Imagine documentaries, news segments, and social media campaigns bringing the invisible threat of space debris to the forefront of public consciousness. These efforts will not only educate people about the dangers of orbital clutter, but also inspire collective action. For example, a viral campaign might showcase the potential impacts of debris on critical infrastructure like satellites, which power everything from GPS to weather forecasting. Storytelling will be key, with narratives that connect the dots between space debris and everyday life, making the issue relatable and urgent. Schools, universities, and community organizations could also take part, hosting workshops and events to spread knowledge and encourage innovation. Public awareness campaigns will not only inform but also empower individuals, businesses, and governments to support cleanup initiatives. By fostering a sense of shared responsibility, these efforts will mobilize resources, drive policy changes, and accelerate technological advancements. The more people understand the stakes, the greater the momentum for creating a safer and more sustainable space environment. This prediction highlights how raising awareness can turn the tide in the fight against space debris, ensuring that the issue receives the attention and action it deserves. Shifting our perspective, let's explore how science fiction has often been a precursor to real-world technological breakthroughs. The portrayal of space debris cleanup in movies and books will not only captivate audiences but also inspire engineers and scientists to turn fiction into reality. Imagine a blockbuster film depicting a futuristic spacecraft equipped with advanced lasers and robotic arms, skillfully navigating through a field of debris to restore safety in orbit. Such visuals can ignite the imagination, encouraging innovators to develop similar technologies. Science fiction has a long history of predicting technological advancements, from space travel to artificial intelligence, and debris cleanup will be no exception. Authors and filmmakers might depict scenarios where humanity faces the dire consequences of unchecked space debris, compelling audiences to consider the real-life implications. These stories could also explore ethical dilemmas, such as who is responsible for cleanup and how to balance technological progress with sustainability. By weaving these themes into compelling narratives, science fiction can serve as a powerful catalyst for innovation. It's not just about entertainment. These stories can spark discussions, influence public opinion, and even shape policy. For instance, a popular book series might introduce the concept of orbital recycling stations, prompting real-world research into similar ideas. Science fiction has the unique ability to make complex issues accessible and engaging, bridging the gap between imagination and reality. This prediction underscores how creative storytelling can inspire practical solutions, driving progress in the field of space debris cleanup while keeping the public informed and invested. Now, let's look ahead to the classrooms of tomorrow, where space debris cleanup will become a core topic in education. Schools and universities are already adapting to the rapid advancements in science and technology, and it's only a matter of time before space debris removal finds its way into STEM curriculums. Imagine students participating in hands-on projects where they design miniature debris capturing drones or simulate orbital cleanup missions using virtual reality. These experiences won't just teach technical skills, they'll also foster creativity, problem solving, and a deeper understanding of the challenges facing our planet and beyond. Courses in aerospace engineering, environmental science, and robotics will likely include modules dedicated to debris removal, exposing students to groundbreaking technologies like lasers, nets, and autonomous systems. Beyond the technical aspects, educators will emphasize the importance of sustainability and global cooperation, preparing the next generation to tackle this issue with a sense of responsibility and urgency. Universities might also partner with space agencies and private companies to offer internships, research opportunities, and real-world applications of theoretical knowledge. Picture a university launching its own small satellite mission to test debris removal techniques, giving students unparalleled experience in the field. This integration of debris cleanup into education will not only inspire future innovators, but also raise awareness about the importance of preserving our orbital environment. By equipping young minds with the tools and knowledge to address this challenge, we're investing in a future where space remains a safe and accessible frontier for exploration and discovery. This prediction highlights how education will play a pivotal role in shaping the future of space debris cleanup, ensuring that the next generation is ready to lead the way. Shifting our focus to the entrepreneurial side of the equation, the rise of startups dedicated to space debris removal is set to redefine the landscape of orbital cleanup. These companies, often born from bold ideas and cutting-edge research, are bringing fresh perspectives and agility to the challenge. Unlike traditional space agencies, startups can move quickly, experimenting with novel technologies and approaches that might otherwise take years to develop. Picture a small team of engineers and scientists working tirelessly to create a compact, cost-effective system for capturing and deorbiting debris, all while operating on a fraction of the budget of larger organizations. These startups are not just developing hardware like nets, tethers, and drones, they're also leveraging software, including advanced algorithms and data analytics, to optimize debris removal missions. What makes these startups particularly exciting is their ability to think outside the box. Some are exploring unconventional methods, such as using magnetic fields or biodegradable materials, to tackle the debris problem in ways that haven't been considered before. Additionally, the startup culture of rapid iteration and risk-taking means that failures are seen as opportunities to learn and improve, driving innovation forward at an unprecedented pace. Many of these companies are also attracting significant investment from venture capitalists and governments who recognize the immense potential of their work. This influx of funding is enabling startups to scale their operations, conduct real-world tests, and even launch their own missions to prove the effectiveness of their technologies. As these startups grow, they're not just solving a critical problem, they're also creating jobs, inspiring new talent, and contributing to the burgeoning space economy. By fostering a competitive yet collaborative environment, these companies are pushing the boundaries of what's possible in debris removal, ensuring that their solutions are not only effective but also sustainable and scalable. The rise of space debris removal startups is a testament to the power of innovation and entrepreneurship, proving that even the most daunting challenges can be tackled with creativity, determination, and a willingness to take risks. This prediction underscores how these startups will play a crucial role in shaping the future of orbital cleanup, paving the way for a safer and more sustainable space environment. Turning our attention to a groundbreaking approach in funding, the future of space debris removal is set to embrace the power of the crowd. Crowdfunding platforms, which have already transformed industries like tech, art, and social causes, will become a vital tool for financing debris cleanup projects. Imagine a world where people from all walks of life, space enthusiasts, environmental advocates, and curious citizens, can contribute to missions that protect our orbital environment. These platforms will allow individuals to support innovative cleanup technologies, from advanced drones to laser systems, by donating even small amounts of money. What makes this approach so compelling is its ability to democratize space exploration and cleanup, giving everyone a stake in the future of our planet's orbits. Crowdfunding will also serve as a testing ground for public interest, helping developers gauge which ideas resonate most with potential supporters. Projects that capture the imagination, such as swarms of tiny debris collecting satellites or artistic installations made from recycled space junk, could quickly gain traction and funding. Beyond financial support, crowdfunding campaigns will raise awareness about the growing space debris problem, educating the public and inspiring a new generation of problem solvers. This model will also encourage transparency, as creators will need to clearly communicate their goals, progress, and challenges to maintain trust with their backers. For startups and researchers, crowdfunding offers a way to secure funding without relying solely on traditional investors or government grants, fostering greater creativity and independence. As more successful campaigns emerge, we'll likely see a surge in collaborative efforts, with individuals, companies, and organizations pooling resources to tackle this global challenge. The rise of crowdfunding in space debris removal highlights a broader shift toward community-driven solutions, proving that when people come together, even the most complex problems can be addressed. This prediction underscores how collective action and shared responsibility will play a key role in ensuring the sustainability of our orbital environment for generations to come. Now shifting focus to the role of technology in accountability, blockchain is poised to revolutionize how we track and verify space debris removal efforts. This decentralized system, best known for its use in cryptocurrencies, offers a secure and transparent way to record every step of a cleanup mission. Imagine a digital ledger that logs the location, size, and type of debris collected, the methods used for removal, and even the organizations or teams responsible. Blockchain's tamper-proof nature ensures that this data remains accurate and unaltered, providing a reliable record of progress. This level of transparency will be crucial for building trust among governments, private companies, and the public, as they'll be able to independently verify the success of cleanup initiatives. It also opens the door for creating a standardized global system for tracking debris removal, making it easier to coordinate efforts across borders. For example, a company in one country could remove debris from a specific orbit, and that action would be instantly recorded and accessible to all stakeholders. This could streamline the allocation of resources, ensuring that no area is overlooked or over-targeted. Blockchain could also be used to incentivize cleanup efforts by introducing token-based rewards for successful missions, which could be redeemed for funding or other benefits. Additionally, this technology could help hold entities accountable for their space debris, as every piece of junk could be traced back to its origin. This would not only encourage responsible practices, but also make it easier to enforce international agreements on space waste. As blockchain becomes more integrated into space debris removal, we'll likely see a rise in collaborative platforms where organizations share data and resources to maximize efficiency. This prediction highlights how innovative technologies can enhance transparency and accountability, paving the way for a more sustainable approach to managing our orbital environment. Moving forward, let's explore how coordinated swarms of small satellites could transform space debris removal efforts. Picture a group of tiny, nimble satellites working together like a well-trained team, each assigned specific tasks to capture and deorbit debris. These swarms could operate autonomously, communicating with one another to efficiently cover large areas of space. Using advanced algorithms, they would identify and prioritize debris based on size, location, and potential threat level. For example, one satellite might detect a piece of debris, while another moves in to capture it using specialized tools like nets or robotic arms. The swarm's collective intelligence allows it to adapt to unexpected challenges, such as debris moving at high speeds or in unpredictable orbits. By dividing the workload among multiple satellites, the swarm could tackle more debris in less time compared to a single, larger spacecraft. This approach also reduces the risk of mission failure, as the loss of one satellite wouldn't derail the entire operation. Additionally, swarms could be deployed to clean up specific regions of space where debris is most concentrated, such as low Earth orbit. Over time, these small satellites could become a cost-effective solution, as they're cheaper to produce and launch than traditional, larger spacecraft. As technology advances, we might even see swarms equipped with solar sails or ion thrusters, enabling them to operate for extended periods without refueling. This prediction highlights the potential of collaboration and innovation, showing how a collective approach could make space debris cleanup faster, more efficient, and more sustainable. With swarms of satellites working in harmony, the dream of a cleaner orbital environment becomes increasingly achievable. Now, let's turn our attention to an exciting development that could redefine sustainability in space: the idea of spacecraft recycling their own debris. Imagine a spacecraft not just cleaning up space junk, but transforming it into something useful like fuel or raw materials. This concept takes the principle of recycling to an entirely new level, leveraging cutting-edge technology to turn a problem into a solution. Picture a spacecraft equipped with advanced systems that can capture debris, break it down, and process it into usable resources. For instance, metallic debris could be melted and reshaped into spare parts, while other materials might be converted into propellant for the spacecraft's engines. This self-sustaining approach would significantly reduce the need for resupply missions from Earth, making long-term space operations more feasible and cost-effective. By recycling debris into fuel, these spacecraft could extend their operational lifespans, allowing them to clean up more space junk without requiring frequent refueling. Additionally, this innovation could pave the way for in-space manufacturing, where repurposed debris is used to build new structures or repair existing ones. The implications are enormous, as it not only addresses the issue of space debris, but also supports the broader goal of creating a circular economy in space. As technology advances, we might even see these recycling spacecraft becoming standard tools for missions beyond Earth's orbit, supporting endeavors like asteroid mining or lunar exploration. This prediction highlights the transformative potential of ingenuity, showing how we can turn challenges into opportunities and move closer to a sustainable future in space. With spacecraft that recycle their own debris, the dream of a cleaner, more resource-efficient orbital environment becomes a tangible reality. Shifting our focus to the future of human habitation beyond Earth, let's explore how space debris cleanup technologies will play a crucial role in building sustainable space habitats. Imagine orbital environments free from the risks posed by debris, where habitats can be constructed and maintained safely over long periods. By removing hazardous debris, cleanup technologies will ensure that these habitats are protected from potential collisions, which could otherwise endanger lives and costly infrastructure. Beyond safety, debris removal will also provide valuable resources for habitat construction. Picture using recycled materials from collected debris to build the very structures that will house astronauts and space settlers. Metals and other materials salvaged from debris could be repurposed into habitats, reducing the need to launch raw materials from Earth and making space colonization more cost-effective. Additionally, these technologies will enable the creation of larger, more complex habitats, as the threat of debris damage becomes less of a concern. Cleanup efforts will also support the sustainability of these habitats by allowing for continuous expansion and maintenance. For instance, debris could be processed into materials for repairing or upgrading habitat components, ensuring they remain functional and safe over time. This integration of debris cleanup and habitat construction will be essential for long-term missions, such as those to the Moon or Mars, where self-sufficiency is key. By addressing the debris problem, we not only protect future habitats but also lay the groundwork for thriving, sustainable communities in space. This prediction underscores how debris cleanup is not just about clearing the way for exploration, but also about enabling humanity to live and thrive beyond our home planet. As we look ahead, it's clear that these technologies will be integral to turning the dream of space habitats into a lasting reality. Now, let's turn our attention to an exciting intersection of technology and adventure: how space debris cleanup will revolutionize space tourism. Picture this, a future where anyone can board a spacecraft and experience the wonders of space without the looming threat of debris collisions. By removing hazardous objects from orbit, cleanup technologies will significantly reduce the risks associated with space travel, making it safer for tourists to venture beyond Earth's atmosphere. This enhanced safety will not only protect passengers but also lower the costs for tourism companies, as they'll no longer need to invest heavily in collision avoidance systems or expensive insurance policies. With debris out of the way, the pathways to space will become clearer and more reliable, paving the way for a booming space tourism industry. Imagine floating in zero gravity, gazing at Earth from above, all while knowing that the skies are clear and secure. Cleanup efforts will also enable more frequent and affordable flights, opening up space travel to a broader audience. What was once a luxury reserved for the ultra-wealthy could become an attainable dream for many. Additionally, debris-free orbits will allow for the construction of space hotels and other tourist-friendly infrastructure, creating a new frontier for leisure and exploration. By tackling the debris problem, we're not just making space safer, we're making it more accessible and inviting for everyone. This prediction highlights how debris cleanup isn't just about protecting satellites and habitats, it's about unlocking the full potential of space for humanity's enjoyment and discovery. As we look to the stars, it's clear that these technologies will play a key role in turning space tourism into a thriving reality. Now, let's shift our focus to another groundbreaking application of space debris cleanup: its role in enabling asteroid mining and resource extraction. As we clear the clutter from Earth's orbit, we're not just making space safer, we're also opening up new opportunities for harnessing the vast resources found in asteroids. Imagine a future where debris-free pathways allow mining spacecraft to travel efficiently without the constant threat of collision. Cleanup technologies will ensure safe navigation, making it feasible to reach asteroid belts and tap into their valuable minerals such as platinum, gold, and rare earth elements. These resources, once extracted, could be used to support space exploration, fuel in space manufacturing, or even be brought back to Earth to address resource scarcity. By removing the debris barrier, we're laying the groundwork for a new era of space mining, where asteroids become the next frontier for human enterprise. This prediction highlights how debris cleanup isn't just about safety, it's about unlocking the potential of space as a source of abundance and innovation. As we look to the stars, it's clear that these technologies will be essential in transforming space mining from a distant dream into a tangible reality. Now, let's consider how space debris cleanup plays a crucial role in the next big leap for humanity: a permanent space colonization. Picture a future where humans live and thrive in space, not just as temporary travelers but as residents of thriving extraterrestrial communities. For this vision to become reality, debris cleanup is absolutely essential. Think about it: space colonies would require safe orbits, clear pathways for supply ships, and reliable communication networks. Without tackling the debris problem, even the most advanced habitats would face constant risks from collisions, making long-term settlements unsustainable. By removing orbital clutter, we create a safer environment for constructing and maintaining these colonies, allowing humanity to expand beyond Earth. Cleanup technologies will ensure that habitats, spaceports, and infrastructure remain intact, paving the way for a new era of interplanetary living. This isn't just about survival, it's about building a sustainable future where space becomes a second home for humanity. As we clear the way, we're not just cleaning up debris, we're laying the foundation for the next chapter of human civilization. Shifting our focus to another essential aspect of space colonization, let's explore how debris cleanup will play a pivotal role in space agriculture. Imagine a future where astronauts on long-term missions or even residents of space colonies grow their own food. For this to work, the environment must be free from the constant threat of debris collisions. Space debris could damage greenhouses, disrupt irrigation systems, or even destroy entire crops, jeopardizing food security for those living beyond Earth. By removing this clutter from orbit, we create a safer and more stable environment for agricultural operations. Cleanup technologies will protect the infrastructure needed to grow crops, such as hydroponic farms and solar-powered greenhouses, ensuring a steady supply of fresh produce. Moreover, debris-free orbits will allow for the safe transport of seeds, equipment, and nutrients to these agricultural hubs. This isn't just about growing food, it's about creating self-sustaining ecosystems that support human life in space for years to come. As we clear the skies above, we're not just enabling space agriculture, we're cultivating the possibility of a truly self-reliant future in the stars. Now, let's consider how space debris cleanup will intersect with the critical field of space medicine. As humanity ventures further into space, the need for advanced healthcare solutions becomes paramount. Space debris poses a significant risk to medical infrastructure in orbit, such as research labs, diagnostic equipment, and even emergency medical capsules. A single collision could disrupt life-saving technologies or delay vital treatments for astronauts. By removing debris, we ensure the safety and reliability of these medical systems, allowing for uninterrupted research into the effects of microgravity on the human body. Cleaner orbits also enable the safe transport of medical supplies and experimental treatments to space stations, supporting groundbreaking studies in areas like bone density loss, muscle atrophy, and immune system changes. Furthermore, debris-free space environments will protect medical satellites that monitor health data in real time, ensuring astronauts can receive timely care even millions of miles from Earth. Essentially, space debris cleanup isn't just about preventing accidents, it's about creating a foundation for the next frontier of healthcare innovation, where the lessons learned in space could revolutionize medicine for people on Earth. As we clear the path above, we're not just safeguarding lives in orbit, we're unlocking new possibilities for healing and discovery. Transitioning to the world of global communication, the removal of space debris plays a pivotal role in ensuring the reliability and efficiency of our communication networks. As satellites form the backbone of everything from internet access to weather forecasting, even a small piece of debris can cause significant disruptions. By clearing out this orbital clutter, we reduce the risk of interference that can degrade signal quality or, worse, destroy critical satellites. Imagine a future where uninterrupted communication allows for seamless global connectivity, enabling everything from telemedicine in remote areas to real-time disaster response. Cleaner orbits also mean fewer delays and dropped signals, ensuring that industries reliant on satellite data, such as agriculture, aviation, and logistics, can operate smoothly. Moreover, as we deploy next-generation technologies like satellite constellations for global internet coverage, debris-free space will be essential to avoid collisions that could cripple these networks. In essence, space debris cleanup doesn't just protect our communication systems, it enhances their potential, paving the way for a more connected and informed world. This improvement in global communication will not only benefit everyday life but also strengthen international collaboration, making it easier to tackle shared challenges on a global scale. Shifting our focus to the broader cosmic environment, space debris cleanup holds immense potential for improving our understanding and forecasting of space weather. Space weather, which includes phenomena like solar flares, geomagnetic storms, and cosmic radiation, can have significant impacts on Earth, from disrupting power grids to affecting satellite operations. With fewer debris objects cluttering orbit, monitoring satellites can operate more effectively, providing clearer data and reducing interference that can obscure critical measurements. This enhanced monitoring capability will allow scientists to detect and predict space weather events with greater accuracy, giving us more time to prepare and mitigate their effects. For instance, early warnings of solar storms could help protect satellites, communication networks, and even astronauts in space. Additionally, cleaner orbits will enable the deployment of more advanced sensors and instruments, further improving our ability to study the Sun and its interactions with Earth's magnetosphere. By removing obstacles in orbit, we not only safeguard our technology, but also deepen our understanding of the dynamic forces shaping our solar system. This progress in space weather monitoring will not only enhance safety and reliability, but also open new frontiers in space science and exploration, helping us navigate the challenges of an increasingly interconnected spacefaring future. Now, let's take a fascinating step into a realm where space debris cleanup intersects with history, revealing stories of our cosmic past. As we clear our orbits of clutter, we'll also unlock a treasure trove of artifacts from humanity's earliest space missions. Imagine sifting through the remnants of defunct satellites, rocket stages, and other discarded objects, each holding clues to the technological and cultural milestones of space exploration. These relics, once lost in the void, could include components from iconic missions like the first satellites launched or the early probes sent to explore our solar system. By recovering these pieces, we'll gain invaluable insights into the design, materials, and engineering of those pioneering endeavors. Think of it as uncovering a time capsule from the dawn of the space age, offering a tangible connection to the dreams and ambitions of those who first reached for the stars. Beyond their historical significance, these artifacts could inspire future generations, serving as a reminder of how far we've come and the challenges we've overcome. Space debris cleanup in this context becomes not just a technical necessity but a journey of rediscovery, preserving the legacy of humanity's first steps into the cosmos. As we clear the skies, we're also making way for a deeper appreciation of our shared spacefaring heritage, blending science with history in a way that enriches both. Shifting our focus to the preservation of space history, let's explore how debris cleanup plays a crucial role in safeguarding our cosmic heritage. As we remove defunct satellites and discarded rocket stages from orbit, we're not just clearing clutter, we're rescuing artifacts that tell the story of humanity's journey into space. These objects, from early communication satellites to experimental probes, are more than just debris. They are tangible records of our technological advancements and bold aspirations. Preserving these artifacts allows us to study their design, materials, and engineering, offering valuable lessons for future missions. Think of it as an archaeological dig in space, where every recovered piece provides a glimpse into the challenges and triumphs of past explorers. Beyond their scientific value, these relics hold cultural significance, serving as reminders of the ingenuity and determination that propelled us into the cosmos. By integrating these historical objects into museums and educational programs, we can inspire future generations to continue pushing the boundaries of space exploration. Space debris cleanup in this light becomes a mission of both preservation and inspiration, ensuring that the legacy of our first steps into the stars is not lost to the void. As we clear the way for future exploration, we also honor the pioneers who paved the path, blending innovation with reverence for our shared spacefaring history. Now, turning our attention to the legal landscape, space debris cleanup is poised to play a pivotal role in shaping the future of space law and regulations. As the issue of orbital debris grows more pressing, governments and international organizations are beginning to establish frameworks to address the challenges of cleanup and accountability. These laws will determine who is responsible for removing debris, how costs are shared, and what standards must be met to ensure safe and sustainable operations in space. The development of these regulations will likely involve complex negotiations, balancing national interests with global cooperation. For instance, questions around ownership rights to defunct satellites or liability for debris collisions will need clear legal answers. Additionally, as private companies increasingly take on debris removal missions, new laws will emerge to govern their activities, ensuring transparency, safety, and environmental responsibility. The evolving legal landscape will also encourage innovation, as companies and nations navigate these regulations to develop compliant and effective cleanup technologies. Ultimately, the intersection of space debris removal and space law will lay the groundwork for a more organized and cooperative approach to managing the orbital environment. By addressing these legal challenges, we can create a framework that supports both the cleanup of existing debris and the prevention of future clutter, ensuring a sustainable future for space exploration. This legal evolution will not only protect our current assets in orbit, but also set the stage for a more collaborative and responsible approach to humanity's continued presence in space. As we shift our focus to the ethical dimensions of space debris cleanup, it's clear that this issue goes beyond technology and law. It challenges us to think deeply about our responsibilities in space. The question of who should take responsibility for cleaning up debris is not just a practical concern, but also a moral one. With thousands of defunct satellites, rocket stages, and fragments cluttering Earth's orbit, the ethical implications are profound. Should the nations or companies that launched these objects bear the burden of cleanup, or does the global community share a collective responsibility to protect the space environment for future generations? These questions become even more complex when considering ownership rights. For instance, if a defunct satellite is deorbited and recycled, who owns the materials recovered? And what happens if debris removal efforts inadvertently damage another nation's active satellite? These ethical dilemmas will require careful consideration and dialogue as they touch on principles of fairness, accountability, and sustainability. Moreover, as private companies enter the debris cleanup industry, ethical concerns around profit motives versus environmental stewardship will come into play. Balancing the need for innovation with the moral imperative to protect the orbital environment will be a key challenge. Ultimately, addressing these ethical questions will not only shape the future of debris cleanup, but also define how humanity approaches its role as a steward of space. By fostering open and inclusive discussions, we can ensure that our actions in space reflect our shared values and long-term vision for a sustainable future beyond Earth. As we delve into the interconnected web of global collaboration, it's undeniable that space debris cleanup will play a pivotal role in fostering international cooperation and diplomacy. The issue of orbital clutter transcends national borders, making it a shared challenge that no single country can tackle alone. This mutual necessity opens the door for unprecedented partnerships between nations, paving the way for joint missions, shared technologies, and unified strategies. Imagine countries setting aside geopolitical differences to work together on debris removal projects, pooling resources and expertise to protect the orbital environment for all. Such collaborations could lead to the establishment of international task forces or multilateral agreements focused on debris mitigation. Beyond the practical benefits, these efforts could also serve as a foundation for building trust and goodwill among nations, demonstrating that humanity's shared interests in space can unite rather than divide. Additionally, space diplomacy could extend to developing nations, ensuring that emerging spacefaring countries have access to debris cleanup technologies and are included in global efforts. This inclusive approach would not only level the playing field but also prevent the creation of new debris from the start. As countries work together to address this pressing issue, the lessons learned in space diplomacy could even inspire cooperation in other areas of global concern, from climate change to resource management. Ultimately, space debris cleanup has the potential to redefine how nations interact in the cosmos, proving that even in the vastness of space, humanity's greatest strength lies in unity. As we turn our attention to the economic landscape, it's fascinating to consider how space debris cleanup could become a cornerstone of the burgeoning space economy. The growing demand for orbital services, from satellite communications to space tourism, hinges on a clean and safe environment. By removing debris, we not only protect existing assets but also open up new opportunities for innovation and investment. Imagine a future where debris removal companies operate alongside satellite manufacturers, offering essential services that keep the skies clear for business. This industry could generate thousands of jobs, from engineers designing cleanup technologies to operators managing removal missions. Additionally, the materials recovered from debris could be repurposed, creating a circular economy in space. Metals, plastics, and other components could be recycled into new satellites, habitats, or even fuel, reducing the need for costly launches from Earth. Governments and private companies alike could benefit from this emerging market, with contracts for debris removal becoming a standard part of space operations. The ripple effects would extend beyond orbit, spurring advancements in robotics, materials science, and artificial intelligence as companies compete to develop the most efficient cleanup solutions. Furthermore, a thriving space economy built on sustainability could inspire other industries to adopt eco-friendly practices, setting a precedent for responsible growth. As debris cleanup technologies evolve, they could also attract venture capital and private equity, fueling further innovation and expansion. Ultimately, the economic potential of debris removal is vast, offering a pathway to a cleaner, safer, and more prosperous orbital environment. By addressing this pressing issue, we not only safeguard our current infrastructure, but also lay the groundwork for a vibrant space economy that benefits all of humanity. With this in mind, let's explore how these advancements could shape the next frontier of innovation and opportunity. Shifting our gaze to the broader impact of these advancements, let's consider how space debris cleanup could become a catalyst for technological innovation across industries. The challenges posed by orbital debris demand creative solutions, and these solutions often lead to breakthroughs that extend far beyond space. For instance, the development of autonomous drones and robotic systems for debris removal could revolutionize industries like construction, manufacturing, and even healthcare. Imagine robotic arms designed to capture debris in space being adapted for precision surgeries on Earth. Similarly, advancements in materials science, driven by the need for durable, lightweight materials for cleanup missions, could lead to stronger, more sustainable products for everyday use. The algorithms and artificial intelligence systems developed to track and predict debris movement could enhance logistics, supply chain management, and even urban planning. Even the recycling technologies pioneered for repurposing space debris could inspire more efficient waste management systems on our planet. The ripple effects of space debris cleanup innovation could be felt in renewable energy, transportation, and communication technologies, as the drive for efficiency and sustainability in space sets new standards for industries worldwide. This cross-pollination of ideas and technologies underscores the profound impact that solving one problem can have on countless others. By pushing the boundaries of what's possible in debris cleanup, we're not just clearing the skies, we're paving the way for a future defined by ingenuity and progress. Turning our attention to the final frontier of this discussion, we arrive at the concept of legacy. Space debris cleanup isn't just about solving a pressing problem today, it's about shaping the future of space exploration for generations to come. By addressing the issue of orbital waste, we're not only preserving the functionality of our current satellite systems and space missions, but also ensuring that future explorers have a clear and safe path to the stars. Think of it as leaving a cleaner, more sustainable environment for those who will follow in our footsteps. The technologies and systems we develop now will serve as the foundation for more ambitious endeavors, from lunar bases to interplanetary travel. Beyond the practical benefits, there's also a symbolic significance here. Our efforts to clean up space debris demonstrate humanity's capacity for responsibility and stewardship, even in the vastness of the cosmos. It's a message to future generations that we cared enough to protect the opportunities they would inherit. This legacy extends beyond technology. It's about fostering a culture of accountability and innovation that will inspire future scientists, engineers, and dreamers. As we look to the stars, let's remember that the actions we take today will echo through the ages, leaving a legacy of exploration unburdened by the mistakes of the past. As we wrap up this journey through the future of space debris cleanup, it's clear that the challenge of orbital waste is not just a technical problem, it's a call to action for humanity. From artificial intelligence-powered tracking systems to orbital recycling stations, these 50 predictions paint a picture of a future where innovation and responsibility go hand in hand. Each prediction underscores the importance of addressing space debris to ensure the safety and sustainability of our activities beyond Earth. Whether it's through groundbreaking technologies, international cooperation, or public awareness, the efforts we make today will shape the trajectory of space exploration for decades to come. Protecting our orbital environment isn't just about preserving satellites or avoiding collisions. It's about creating a legacy of exploration that future generations can build upon. The advancements we've explored here are more than just possibilities, they're pathways to a cleaner, safer, and more prosperous future in space. So, what can you do to be part of this movement? Stay informed, support initiatives that prioritize space sustainability, and share this knowledge with others. Together, we can turn these predictions into reality and ensure that the stars remain within our reach. Don't forget to like this video, subscribe to the channel, and hit the notification bell to stay updated on the latest in futuristic technologies. The future of space is in our hands, let's make it a bright one.